Welcome to our channel Sankalp Study Success. Today in this video, we are going to learn about random variables and the types of random variables. There are two types of random variables which we are going to see here. So, two types of random variables and what is the random variable. So, let us proceed. Here, what is a random variable? Now, let S is a sample space of random experiment. Then, the random variable X is a function from S to R. That is, X maps from S to R. That assigns a real number X of S to each sample point which belongs to S. That means what here there is a sample space S and also a random variable X which is mapping from S to R. And also this assigns a real number X of S to each sample point which is belonging to S. Okay, this is the random variable actually. This random variable is also known as chance variable, or you can say it as stochastic variable. So random variable is known as chance variable and also stochastic variable. See here, it is the second point. It is also called as. So now, the third one is the set of all possible values taken by the random variable X is called range of X. That means all the possible values that are taken by the random variable X. By the random variable X, if you take any possible number of values this X is taking, that is known as range of X. And it is always subset to the real number R. Range of X is always subset to real number R. Here, random variables are denoted by capital letters. And the values which are assigned to random variables, that means the particular values that random variable is taking, those are denoted by small letters here. So capital letters and small letters. Now, what are the types of random variables? There are two types of random variables. Those are discrete random variable and second one is continuous random variable. Now, first let us discuss about discrete random variable. A random variable takes only finite or countably infinite number of values. That means what? If it is taking only finite number of values, then it is known as discrete random variable. For example, number of telephone calls received by the telephone operator. The telephone calls which you have received, he will be having the count of number of telephone calls received. That means you can count it. That means they are only finite. So you can say that it is a discrete random variable. Number of accidents on highway, number of children in a family, marks scored by a student in an exam. So these are some of the examples of discrete random variable. So what is a discrete random variable? It is just if the variable takes only finite number of values, it is known as a discrete random variable. Now let us see what is continuous random variable. Here, exactly opposite to discrete. That means what? If it takes non-countable infinite number of values, that means here we are taking finite and in continuous we are taking infinite number of values. For example, height. Height will be belongs to 4, 5. See, height, weight, age, temperature and time, all these are infinite. That means you cannot say the height of each and everyone in this world, right? So that means what? It is a continuous random variable. So discrete is nothing but it takes only finite values and continuous is nothing but it takes only infinite values. So this is about types of random variables. Now let's see in detail discrete probability distributions. We are going to see what are discrete probability distributions and what are continuous probability distributions. So here the first one is probability mass function. Suppose X is a discrete random variable which is taking the values from x1, x2 and so on up to xn with corresponding p1, p2 and so on up to pn, which are nothing but a probability mass function of random variable x. Then it is denoted by f of xi is greater than or equal to 0 or p of xi is greater than or equal to 0, where I is positive integers from 1, 2, 3 and so on up to you can take it till infinity also. So here Now this is the first one where f of xi should be greater than or equal to 0 or p of xi should be greater than or equal to 0. Here the second one is summation of f of xi is equals to 1 or sum of all the probabilities should be is equal to 1. If it satisfies these two conditions, then it is a probability mass function. So now let us see the probability distribution of random variable x. How you will distribute? Here x is a variable and p of x is equals to xi is nothing but a probability. So here we are denoting x with x1, x2, x3 and so on up to xn, and the probabilities from p1, p2, p3 and so on up to pn. So now if you are asked to find p of x is less than or equal to xi, then it is p of x equals to x1 plus x2 and so on up to xi, till where the question is asked, and till there we will just add all the probabilities. So in the same way, these are just to practice. So now let us see what is the cumulative distribution function. Cumulative distribution function is, here let x is a discrete random variable taking these values with these probabilities. Then cumulative distribution function can be denoted as p of x less than or equal to x. Okay, this is denoted by capital F of x, which is equals to p of x less than or equal to x. We will use it in most of our problems. In if we solve the problems, then we will come to know. Now there are few properties. If a is less than x less than or equals to b, then f of b minus f of a. If both are equal, then p of x equal to a plus f of b minus f of a. So there are the 7 formulas which we have, which you have to remember. But if you don't remember, also you can solve the problems, but these are the important thing, only we have to remember it. Now let us see continuous probability distributions. Till now we have seen discrete probability distributions. Now let us see what is continuous probability distributions. In the continuous probability distributions, we are having probability density function, but previously in discrete probability distributions we were having probability mass function. So let us see what is probability density function here. It is of a probability density function of a continuous random variable x. It is denoted by f of x, and it should satisfy two conditions. What are those conditions? Is if f of x is greater than or equals to z, it should be greater than or equal to 0, and also this f of x dx integration of minus infinity to plus infinity f of x dx is equals to 1. Okay, these are the two conditions it should satisfy. Then coming to the cumulative distribution function, how will you distribute in continuous probability distributions? So here the formula is f of x is equals to integration of minus infinity to plus infinity f of x dx. This is the formula. Here we will use this formula in order to find the continuous probability distributions. So here in the same way as we have in the discrete probability distributions, here also we are having some of the properties which you have to just remember them exactly. Now let us see some of the problems related to discrete probability distribution. Then we will go into the problems of continuous probability distribution. Here it is given that if x is a random variable, then the distribution of the probability distribution is given in the form of a table. Here we have to find the value of k. Value of k is nothing but, we know that probability sum of all probabilities is equals to 1, right? So let us solve the first thing first. We know that sum of all probabilities is equals to 1. So if you add all these probabilities and if you equate to 1, then you will get the value of k, right? So 0 plus k plus 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k, which is equals to 1. So in this case, if you add all the probabilities and if you equate to 1, then you will get the values of k. That means here it is 3k plus 2k is 5k, plus 2k is 7k, and this is 8k, and this is 9k. And here 7, 8, 9 and 10. So we are having 10k square plus 9k is equals to 1. So from this quadratic equation, you will get the k values as -1, 1 by 10. So in this way, we can find out the values of k. Now, the second one is you have to find p of x less than 3. Less than 3 is nothing but it is 0, 1 and 2, correct? So by adding all the probabilities of 0, 1 and 2, you will get the probability of p of x less than 3. So let us solve here. P of x less than 3 is nothing but p of 0, x is equals to 0, plus p of x equals to 1, plus p of x is equals to 2. So probability of 0, which is given as 0 only. Probability of 1 is nothing but k, plus probability of 2k is probability of 2 is nothing but 2k. So we will get the value of this as 3k. That means 3k is nothing but 3 into k value is nothing but 1 by 10, right? That is nothing but 0.3, because we are considering the positive value. So we will get the answer as 0.3 here. So this is the second one. Now let us see what is the third question. Third one is 3 less than x less than 6. That means what? Probability of 3 less than x less than 6 is nothing but probability of x is equals to 4 plus probability of x is equals to 5, because here 3 and 6 are not included, so we are not taking the values of 3 and 6. So probability of x equals to 4 is 3k and probability of x is equals to 5 is k square. That means 3k plus k square. That is nothing but 0.3 plus 0.1 whole square. That means if you solve this problem, then you will get it as 0.31. This is the value of probability which is lying between 3 and 6. Now let us see. This is the fourth one, right? Oh, we missed the third one. Okay. P of x greater than or equals to 3. That means what? From 3 you have to add all these values in order to get the value. So let us solve this. This is the fourth one actually. So let us solve the third question here. Probability of x greater than or equal to 3. Sorry, it is not 6. That is equals to 3. So that means probability of 3 plus 4 plus 5 and so on up to 6. That is 4 plus 5 plus 6. So these are the values which we get from probability of x which is greater than or equals to 3. That means all the values, if you add from 3 to 6, then you will 3 to 7, right? It is not only 6, it's 7. Up to 7, it is given up to 7, right? So we have to add from 3 to the end, that is 7. So now if you add all these values, that is here you will get 5k plus k is 6k, okay? 6k plus here 7, 8, 9 and 10k square. That means you will get it as 0.6 plus 100 into 0.1 whole square. So you will get the answer as 0.7. Okay. If you add these values, then you will get it as 0.7. So in this way, you have to take the values and you have to add. Here we have to find out the mean here. Mean, variance and standard deviation. So in order to find the mean, which is the fifth one, right? Mean. Mean is nothing but, here we know that P of x is equals to summation of x is equals to 0 to 7, because there are 7 values, right? 0 to 7 xi into pi. That is nothing but you have to just multiply these two and then you have to add. That means 0 into 0 is 0 plus if you multiply and add 1 into k is nothing but k is nothing but 0.1 plus so on like that. If you add up to the 7th value, which is 7 into 7, 49k square plus 7k, that is plus 7k. So if you add all these values and divide by number of, do you need to divide? No, right? Because we are just directly applying into the formula. So there is no need to divide here. So you will get the answer as mu is equals to E of x is nothing but mu, right? Mu is equals to 3.66. This is nothing but the mean of the given distribution. So the sixth one is we need to find the variance. How do we find the variance here? We know that B of x, that is equals to sigma square also. So sigma square, it is equals to E of x square minus E of x whole square. So here, what is E of x square? E of x whole square, you got it, 3.66. But here, E of x square, you have to find out 0.1 plus 0.8 plus 1.8 plus and so on up to 7 values minus 3.66 whole square. So this is the variance. Now if you solve it completely, then you will get it as 3.4044. This is the variance. So in order to find standard deviation, which is nothing but the square root of 3.4044, right? So the square root of 3.4044 is nothing but 1.845. So in this way, you have to find out all the values by just applying the formula. Now let us see the second question, which is also very important question. This is the most repeated question actually. Once it will be asked for maximum, and also sometimes it might be asked for minimum also. So here, let x denotes maximum of two numbers that appears when pair of dice is thrown. Okay, so maximum of two numbers will be appeared. So let us write what all will be appeared in the top. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6, right? This is with 1. If it is with 2, then 2, 1, 2, 4, 2, 5 and 2, 6. Then with 3, it is 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. Again you have to write it with 4, you have to write it with 5 and also you have to write it with 6. Let us write it here. Because each die has the 6 faces. So this is 4, 4, this is 4, 5 and this is 4, 6. This is 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. Here it is 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So these will be the values which you will get on the pair of, if you throw a pair of dice, then you will be getting these many number of values, that is these many, that is what it is, 36 values you will get it. So from here you have to find out the maximum of two numbers that appears and also find the discrete probability function. So in this one we have to just find discrete probability function, that is nothing but the discrete probability function table you have to draw for x and also for p of x, that is for maximum of two numbers appearing on the dice. That is, let us solve it here. See, if p of x is equals to 1, that means if 1 is the maximum, then only this is the maximum, right? There is nothing where 1 is greater than some other number. So we are having only 1 by 36. If p of x is equals to 2, then what happens? If it is 2, this is the greatest and this is the greatest and this is the greatest. That means we are having only 3 in the L shape, right? We are having only 3. So it is 3 by 36. Now, if x is equals to 3, how many maximum pairs do we get? 1, 2, 3, 4 and 5. we will get 5 by 36. In a similar way, you have to find out for p of x equals to 4, p of x equals to 5 and p of x equals to 6. This is nothing but 7 by 36 and it is nothing but 9 by 36 and this is nothing but 11 by 36. So in this way, we have to find out the probability of getting the maximum number. So the first one, probability distribution table we need to draw. So x, where 1, 2, 3, 4, 5 and 6, these are the greatest number, maximum numbers which appears on the dice, and here the probability of each and every number. That is what 1 by 36, 3 by 36, 5 by 36, 7 by 36, 9 by 36 and 11 by 36. So this is the probability distribution table, probability, discrete probability function. So in the same way, we have to also find cumulative distribution function. So let us see the second one, cumulative distribution function. In order to find cumulative distribution function, first of all, f of 1. For the first one, you have to find out. That means what? P of x is less than or equals to 1. Less than or equals to 1, it is nothing but 1 by 36 only, right? Which is from the table you can see. Now, f of 2, which is nothing but P of x is less than or equals to 2. If it is less than or equal to 2, that is nothing but 1 by 36 plus 3 by 36, which is equals to 4 by 36. So this is the value of f of 2. Now, for f of 3, which is equals to P of x less than or equals to 3, that is 1 by 36 plus 3 by 36 plus 5 by 36, which is equals to 9 by 36. Now, for f of 4, you need to find it for f of 4. P of x less than or equals to 4, which is you have to add all these values up to 4, right? That means what? 1 plus 3 plus 5 plus 7. 16 by 36 you will get it as. Now let us solve for f of 5 and also for f of 6. If you add all those values, that means p of x less than or equals to 5 and p of x less than or equal to 6, then the values you will get is 25 by 36 and 36 by 36, which is equal to 1 here. Okay, so now this is the continuous distribution function. Now we have to find mean, variance and standard deviation here, because which is e of x is nothing but mu, variance is nothing but sigma, which is sigma square, sorry, and standard deviation is nothing but sigma. So we have to find mean, variance and standard deviation. So in order to find mean, variance and standard deviation, so this is the third one, mean, that is e of x, which is nothing but mu. Then here you have to add each and every term, you have to multiply and add, right? Because here we have drawn the distribution table, 1 into 1 by 36 plus 2 into 3 by 36 plus 3 into 5 by 36, like that you have to add up to 6 into 11 by 36. So let us solve it. Into 3 by 36 plus 3 into 5 by 36 plus 4 into 7 by 36 plus 5 into 9 by 36 plus 6 into 11 by 36. Now if you find the value, if you calculate this value, then you will get it as 4.472. This is the value. Now coming to the variance, which is sigma square. Here it is written as e of x square minus e of x whole square. So this is nothing but sigma square. So we will find e of x square and we will subtract with this value 4.472, right? So now e of x square can be written as 1 by 36 plus 4 into 3 by 36 plus 9 into 5 by 36. Yes, so because 1 square is 1, 2 square is 4, 3 square is 9, plus 16 into 7 by 36, plus 5 square is 25 into 9 by 36, plus 36 into 11 by 36 minus 4.472 whole square. So now here this value will be equals to 0.1984. So this will be the value of sigma square. Now if you find the value of sigma, that is nothing but square root of sigma square, which is equals to 1.984, square root of 1.984, then you will get it as 1.40. So this is the value, sorry, it is not 0 point, it is 1.984. That is, so in this way you have to find out the mean, variance and standard deviation. So now let us see the third question which is given here. This is the most important question and you have to try to solve it also. A box contains 4 white balls and 6 black balls here, and a man drawn 2 balls and is given rupees 140 for a white ball and 70 rupees for the every black ball. Then what is his expectation in the game favorable to the player? That means what here? Let us consider x as number of defective balls first of all. Okay, x as number of defective balls, then the probability of getting 0 defective balls is how much? Let us see here. Probability of getting 0 defective balls. That means probability of x equals to 0, which is equals to 7c3 by 10c3, correct? Okay, because there are 10 balls which are 4 plus 6, right? 4 plus 6 is nothing but 10. So if you are drawing 3 balls from the here it is not 2 balls, if it is he is drawing 3 balls, so then it becomes 7c3 by 10c3. So here we are going to find out this value, which is nothing but 7 by 24. So here it is given that probability of getting 0 defective balls, but if the probability of getting 1 defective ball, let us find out for probability of getting 1 defective ball. That means P of x is equals to 1, which is nothing but here it is 3c1 into 7c3 by 10c3. Okay, so by finding this value you will get it as 21 by 40. Now in the same way you have to find out for P of x is equals to 2 and also for P of x equals to 3. So if you find out all, you have to find out all these values. Then if we draw a distribution table, that means probability distribution table, then you can get the expectation is the game favorable to the player. Expectation is nothing but mean. So this is the most important problem. In a similar way you have to solve it by just using the formula. So if you draw the distribution table, then finding the mean of the distribution table is very easy, right? Just you have to find out P of x equals to 2 and x equals to 3, and you have to draw the table which is 0, 1, 2 and 3 and the probabilities of x is equals to xi. Okay, so in this way you have to find out this problem, which is the most important problem. Try this problem. If you have any doubts, you can post it in our chat box or you can mail to us. Okay, now let us see one problem related to continuous probability distribution. But in the final exam both are equally important, but little bit most important is the discrete probability distributions. So here it is given that density function f of x is equals to x by 6 plus k, where k lies between 0 to 3, right? Here we need to find 0 to 3, otherwise it is 0. So that means what? If this lies between 0 to 3, then only it is x by 6 plus k, otherwise it is 0. So now let us see here. have to find out the k value. That means, how do we find out the k value? Probability of sum of all probabilities is equals to 1. We were doing till now. But in the continuous probability distribution, we have to integrate it from minus infinity to plus infinity. We know that here if we integrate from minus infinity to plus infinity, f of x dx is equals to 1. So what will be the limits from 0 to 3, right? So f of x is x by 6 from 0 to 3. Correct? X by 6 plus k, right? It is not just x by 6 dx. It is x by 6 plus k of dx is equals to 1. That means here if we integrate, x integration is x square by 2. So there is 6 here. So x square by 12 plus kx. If you apply the limits from 0 to 3 and if you equate it to 1, then you will get it as k value. Now substitute 3 first, which is 9 by 12 plus 3k minus, if you substitute 0 then it is 0 only, which is equals to 1. So from here you will get the k value as 1 by 12. So in this way we will find the value of k. So in the continuous probability distribution, if we have to find out probability of 1 less than x less than 2, that means you have to integrate from 1 to 2. That means the limits are from 1 to 2, which is equals to f of x dx, and the limits are from 1 to 2. Here, we already know that value of k is 1 by 12. So we will substitute x by 6 plus 1 by 12 dx from 1 to 2. Now if you integrate this, x by 6 is nothing but x square by 12 plus 1 by 12 into x. From 1 to 2. Limits are from 1 to 2. So now let's substitute upper limit and then we will substitute lower limit. Plus 2 by 12 minus 1 by 12 plus 1 by 12. Okay. Now, if you solve this, if you calculate it, then you will get it as 1 by 3. So this is the value of probability lying between 1 and 2. Now, we need to find out the mean of the continuous probability distribution, right? Which is mean. Now, how do we find out mean? Here, E of x, that is nothing but mu, which is equals to, the formula is x into f of x dx, right? Integrate from minus infinity to plus infinity. Okay, but our limits are from 0 to 3 only, correct? So x into f of x is nothing but x by 6 plus 1 by 12 dx from 0 to 3. You have to just integrate it from 0 to 3. That means x into x by 6 is x square by 6 plus x by 12 dx integrated from 0 to 3. Then you will get it as x square by 6 is nothing but x cube by 3, that is 6 3s are 18, plus x square by 2, that is nothing but x square by 24. So applying the limits 0 to 3. If you apply the limits, then what happens is 3 cube is nothing but 27 by 18 plus x square, 3 square is 9 by 24 minus, we have substituted upper limit and then by applying lower limit which is 0, if you substitute 0 then it is again 0, right? So it is 0 only. So by solving this, E of x, that is mu, you will get it as 15 by 8. So this is the value of mean. Now we are going to find out what is the variance. Variance. Variance is nothing but here V of x is equals to E of x square minus E of x whole square. So we have already found E of x whole square value is nothing but 15 by 8 whole square. But here you have to find out E of x square also. So x square into f of x dx is nothing but the formula which is minus infinity to plus infinity and minus 15 by 8 whole square. This is equals to x square into x by 6 plus 1 by 12 into dx from 0 to 3. If you integrate it and if you substitute the limits, then you will get the variance as 39 by 64. So this is the variance value. In this way you have to find out the mean and variance, and we know that standard deviation is nothing but it is just the square root of the variance, which is nothing but square root of, we got the variance as 39 by 64. So standard deviation value you will get it as 0.78. So in this way you have to find out the mean, variance and standard deviation. So this is about discrete probability and also continuous probability distributions. Thank you for watching the video.